So on to problem number 9 of the MIT integration book of example 15. The definite integral from x equals to 0 to x equals to 2 of x over the product of x minus 3 and x plus 5 squared. So this problem, I think the main focus here is to try and separate this fraction into partial fractions, and then from there you can, I think, be able to solve it. So let's see how we may be able to solve it. So this is our problem. Integral from x equals to 0 to 2 of x over x minus 3 x plus 5 squared. So the first thing is to try and break this down into partial fraction. And how we may be able to do this is the same as x minus 3 b over x plus 5 and c over x plus 5 squared. And so when you multiply these across this side, we have a times x plus 5 squared plus b x minus 3 x plus 5 plus c x minus 3. Okay, so we've said that our x is the same as a x plus 5 squared plus b x minus 3 x plus 5 plus c x minus 3. So let's expand this out so that we have x squared plus 10x plus 25. For b, we have x squared plus 2x minus 15 plus c x minus 3. So this is the same as a plus b x squared plus 10a plus 2b plus c x, and then we have plus 25a minus 15b minus 3c. So this equals to 0, this equals to 1, since we have a 1 here, and then this is equals to 0. Okay, so a plus b equals to 0, meaning that a is equals to negative b. 10a plus 2b plus c equals to 1, and we can borrow this here so that we have 10a minus 2a plus c equals to 1, and this becomes 8a plus c equals to 1. The same thing we can do here. 25a minus 15b minus 3c equals to 0, since a is equals to negative b. Or b is equals to negative a. That means we can say 25a plus 15a minus 3c equals to 0. So essentially what we have is, this is 40a minus 3c equals to 0. So what this tells us is that c equals to 40a over 3, right? So we're going to now summarize a few things. So we saw that a is equals to negative b. We saw 8a plus c equals to 1. And we also saw that c was equals to 40a over 3. So we can go ahead and substitute this here, so that 80a plus 40a over 3 equals to 1, which means that if 3 is the common denominator, we have 24a plus 40a equals to 1. That means 64 over 3 equals to 1, meaning that a is equals to 3 over 64. And therefore b would be equal to negative 3 over 64. Okay, and c would be equal from here. C would be equal to 40 over 3 times 3 over 64 would cancel, by 4 10, by 4 16, 5, by 2 8. So just say a is equals to 3 over 64, b equals to negative 3 over 64, and c would be equal to 5 over 8. So our fraction x over x minus 3, x plus 5 squared, is the same as 3 over 64. Let's extend this by a little bit. X minus 3 minus 3 over 64. Extend that, x plus 5 plus 5 over 8. Extend that, x plus 5 squared. Right. So that our integral from x equals to 0 to 2 of x over x minus 3, x plus 5 squared, the same as 3 over 64, integral from 0 to 2 of 1 over x minus 3, plus, that's minus actually, minus 3 over 64, integral from 0 to 2 of 1 over x plus 5, plus 5 over 8, integral from 0 to 2 of 1 over x plus 5 squared dx. So it's very important to take note here, right? Because this part is negative in this regime, 0 to 2. And so when you do integrate, this becomes a natural logarithm of x minus 3. So we can also express this as negative 3 over 64, 0 to 2, of 1 over 3 minus x, right? So we've just reversed things here. Minus 3 over 64, 0, 2, x plus 5, x plus 5 over 8, 0, 2, 1 over x plus 5 squared. So that when we integrate this, it becomes a negative. So we have a negative 364 of negative natural logarithm of 3 minus x, 0, 2, minus 3 over 64, natural logarithm of x plus 5, 0, 2, and then minus 5 over 8, 1 over x plus 5, because 1 over x plus 5 squared integrated is a negative of 1 over x plus 5. This is 0 to 2. So this negative and that cancel. So we have 3 over 64 log of 1 minus log of 3 minus 0 is 3 minus 364 log of 7 minus log of 5, and then minus 5 over 8, 1 over 7 minus 1 over 5. Okay, so what we can do is this tends to 0, right? And then we can bunch things together because this is a common. We can, this minus and this minus interact, so it become a positive for this. What we have here is 3 over 64 open bracket log 5 minus log 7 minus log 3, okay, minus 5 over 8, we had 1 over 7 minus 1 over 5. Okay, so 3 over 64 log, using rules of logarithm, we have 5 over 21. And then we can swap things here. We have 5 over 8 times, this is 35, 7 minus 5, which is 3 over 64 log 5 over 21 plus 5 over 8 times 2 over 35 by 5, 1 by 5, 7, 1, 2, 4, so 1 over 28. So we have 3 over 64 log of 5 over 21 plus 1 over 28. So quite an interesting problem, but we can say that our integral from x equals to 0 to 2 of x minus 3, x plus 5 squared equals to 3 over 64 natural logarithm of 5 over 21 plus 1 over 28. And that, ladies and gentlemen, is our answer.